Okay, students, Assalamu alaikum. Welcome to the lecture of week 2, the course titled Introduction to Databases. So if you can hear me, please raise your hand. Okay, good. So in our face-to-face class, we came to know about Introduction to Databases and what database management system is, and I told you about some of the basic terms using databases like database models, then what is SQL language, and so forth. So in this virtual session, because I have completed my lecture slides in the class, and I have also showed you the video of this week in the class. So I want to just give an overview of the contents again in this class, and if you have any question, then you can ask me. So let's start. So I told you about database management systems, which contains information about a particular enterprise. It is a collection of interrelated data in some sequence. It's a collection of set of programs which is used to access the data, and an environment which is convenient and efficient to use to access the database. Then I told you about the database applications which are in banking, which are in airline, university, sales, and other fields. And I told you the databases can be very large and touch all aspects of our lives. Then when I say that there is a set of programs to access the data, it means the programs can be for different purposes, like to add students, to add instructor, to add courses, or to register students for courses. So our previous file system has certain data drawbacks, because of which we have moved towards databases. The drawbacks were of data redundancy and inconsistency. We were having multiple file formats, and we were having duplication of information in different files. And also it was difficult to access data, because to perform each operation we were required to write a new program, and which was a difficult task. And then there were multiple files in multiple formats. When you are going to access data, the data was placed in different formats. So there was no uniform interface to access data. It was difficult. And then there were integrity problems. There were integrity constraints, because to access a particular piece of code, piece of instruction from a program, or explicitly, was difficult. And then when you have written a set of instructions, to change the existing instructions, or to add or to modify, or to add something new in it was also difficult. And then there were problems of atomicity of updates. There were problems to have concurrent accesses by multiple users, and there were some certain security problems, because of which we have left file system and have moved towards the databases. Then I told you about the physical level of database, the logical level, how data is logically saved, and what is the view level, where application programs are actually interacting with your database. So this is the architecture, a view level, view 1, 2, up to view n. Then this view level is this is for application, and then there is a logical level, and this is a physical level on which actually database is stored. Then I told you about instances and schemas, similar to types and variables in programming languages. Schema is a logical structure of database. Like, for example, if I say the database consists of information about a set of customers and accounts and the relationship between them. So when we say physical schema, database design at the physical level. When I say logical schema, it is design at the logical level. So it is actually referring to the design. So schema is actually the design of database, how it is constructed. And when I say instance, it is the actual content of the database at a particular point of time. For example, if I say that a variable A is of type integer and has a value at a particular point as 1 to 3. So when I'm defining a variable as integer, then it is a schema, and when I say that A equal to 1 to 3, then it is an instance of that variable, a value of that variable at a particular instance of time. Similarly, the contents of data at a particular point in time is called the instance of a database. Then physical data independence is required because the ability to modify the physical schema without changing the logical schema is important. Applications are actually depending on the logical schema. The interfaces between the various levels and components should be well defined so that changes in some parts do not affect others. So data independence at physical level is required. When I say talk about data models, it's a collection of tools for describing the data, how we can model the data, how we can model the relationships, its semantics, and its constraints. And I told you about certain models which exist to model the data. I told you that there is a relational model as well, which we'll be studying in Chapter 2, in which data is modeled in the form of a table, in which there are certain fields like ID, name, department name, and salary, and there are certain rows which are called records. And there are multiple tables which can exist, like sector table, the department table. Then when you have defined your data, you have defined your schema. Then when you want to access the data, or you want to modify the database, you have to use certain language to perform operations on that data. So language for accessing and manipulating the data organized by the appropriate data model, it is called data manipulation language, and it is also sometimes known as query language. There are two classes of query language, procedural and non-procedural. When I say procedural, in which users specified what data is required and how to get that data. So that is procedural language, when user knows exact details of where data is placed. And when I say declarative and non-procedural language, it means the user specifies what data is required without specifying how to get those data. It means non-procedural languages are better than procedural languages because users need not to worry about where the data is placed and how the data will be accessed. SQL, sequential query language, is the most widely used query language. So when I say before using the data manipulation language, we need to define data. So the language which is used to define data is also SQL. The specific notations are used to define a database. For example, when we want to create a table with a title instructor, then we use create table instructor command, and we specify all the arguments which are required in it. Then a table DTL compiler generates a set of table templates and store it in a data dictionary, which contains information about all the database schemas, what kind of database design is there, then the constraints about integrity. For example, what is the primary key, what is the referential integrity value, and then who is authorized to use that data. So this information is kept by data dictionary. Then when I say that SQL, it is a widely used non-procedural language. For example, when you want to find the name of instructor with the ID 22222, then you can write query such as select name from instructor. And similarly, when you want to find the ID and building of instructor, then you can write similar queries. So how you can write queries, what is the steps required, we'll be studying later. Then when you say that this is a database design, so is there any problem with this design? So I asked this question in class, so anyone has found the answer to this question? If you have, please send me a message or raise your hand. All the people who are already raising hand, please undo it. I'm not able to know that who is going to answer my question. So please, all of you who have already raised hand, please keep your hands down, and then who is willing to answer, please either send me a message or raise hand. Be sure your chat permission is now turned on, so you can send me a message or you can raise hand if you want to answer this. Okay, let me continue with my lecture, then get the answer to this question, and I'll ask you about it in the end. Okay, let's skip this. Then I told you about the entity relationship models. Which models an enterprise as a collection of entities and relationships. And entity is a thing or object in an enterprise that is different from the other objects. It has certain set of attributes, and it is related to to other entities. It can be related to one entity, or it can be related to multiple entities. When you want to represent it diagrammatically, by a diagram, the diagram is called entity relationship diagram. Here you can see that there is a table of instructor, entity of instructor, entity of department, and entity has certain attributes like ID, name, salary is the attribute of instructor, then department name, building, and budget is the attribute of department, and instructor is a member of department. There is a member relationship between these two. Then the data model can be object relational data model. The relational model is flat atomic values, where certain attributes can belong to one single entity, and some of the attributes can exist in some other but are related to only one entity. In object relational data models, the relational data model is extended by including object orientation and construct to deal with added data types. Besides the built-in data types, the other data types can also be the other data can also be handled. Allow attributes of tuples to have complex types, including non-atomic values such as nested relations. So the attributes of tuples can be of user-defined types as well, and the relationships can also be nested. Like, because in object relational databases we have different kinds of relationships, we can have different kinds of relationship as well. So these relationships can be modeled in object relational data model. Preserve relational foundations, in particular to the declarative access of data, while extending modular power. So declarative access, the relations foundation is preserved, in particular to declarative access to data, and you are preserving the modeling power as well. So and it provides, object relational data model provides upward compatibility with the existing relational languages as well. So this is another advantage of object relational data model. Then another way to model data is using XML, Extensible Markup Language. It was defined by World Wide Web Consortium, which is called W3C, which is a consortium of all the people using the World Wide Web. And you can read, you should read more about it, about W3C consortium. Originally intended as a document markup language, not a database language, but now it is used for databases as well. The ability to specify new tags and to create nested tag structures made XML a great way to extend data, not just documents. So new tags can be specified, the structures can be tagged. These are the plus points of XML, which made it feasible, or which made it more suitable for to be used as database language as well. XML has become the basis for all new generation data interchange formats because it is compatible with World Wide Web as well. So the applications who are being run over the web can also access the database using the XML language. And the wide variety of tools is available for parsing, browsing, and querying XML documents and data. So what is one of the big advantage? Because of it, we prefer to use XML for data access. Then we talked in a class about storage manager, that there is a storage manager above the physical structure of database, and above the between the application layer and between the physical layer, there is a storage manager. It is a program module which provides the interface between low-level data storage and application programs. It is responsible for two tasks. The first one is to interact with the file manager at lower level where your data is actually stored, and then to efficiently store, retrieve, and update the data in that file system. So when you want to retrieve, it means some application has requested that retrieval should be fast, efficient. And when it is going to store, that storage should be efficient in using the file system. But the problem the storage manager faces is to access of storage, how to organize file, how to perform indexing and hashing for quick retrieval of information, quick retrieval of data. So if the indexing and hashing is done efficiently, then data can be retrieved more quickly. So it reduces the time of database data retrieval. Then I told you about query processing, that basically 3 steps are performed in every query processing. The first one is parsing and translation, which is done by parser and translator. When you input a query, initially it goes to the parser and translator, which converts it into a relational algebraic expression. Then this expression is given to the optimizer for optimization, which makes an execution plan, that how it will be executed to access from the database. Then there is an evaluation engine which actually performs the processing of the query, like by using, for example, like you want to store something on the data, or you want to retrieve something from the data, then evaluation engine is actually responsible to execute your query, and then it generates an output which is given to you. Transaction management in database is also very important, because if your system fails in the middle of a transaction, then you need to keep your database consistent. Similarly, if more than one user is concurrently updating the same data, then the database should remain error-free. It should not be damaged. It should not have errors. So if more than one user is concurrently updating the same data, so then we need to manage it properly. So when we say we are doing the transactions, it means we are performing a collection of operations that is actually performing a single logical function in a database application. For example, we are registering a student in a university database. A student is going to register a course in a university database. That is one transaction. A teacher is going to upgrade the grade of one student or to mark the grade of one student in the database. This is one transaction. So to mark that grade, the multiple operations need to be performed on the database. But the collection of that operations, which are performing a single logical function, is called a transaction. So two components are there to do this. One is the transaction management component and one is the concurrency control manager. Transaction management component is actually ensuring that a database remains in a consistent state despite system failure. For example, during the transaction, if some system failure occurs because of anything, because of power failure, because of operating system crashes, because of some deadlock or anything, so then it should keep the data in consistent form. Either the transaction should be performed or it should not be performed. So all the steps should be approved or the steps should be cancelled. So this is the responsibility of this component to keep the database consistent. Another one is the concurrency control manager, which controls the interaction among the concurrent transactions. When two processes or two programs are trying to modify the same data, then the concurrency control manager controls this interaction so that the data remains consistent. So these are atomic operations which the manager controls. Then I told you about who can be database users or who can be administrators. On the top level of database, there exist multiple things, multiple programs and users are interacting with your database. The first one is the naive users, tellers, agents, website user. For example, you are registering course through your SCU website, then you are a user. You are a web user. What you are using? You are using an application interfaces. You are using your web browser, your Chrome or Internet Explorer to access database. Then that is your application interface. So you have to interact with the database. The second one, application programmers write application programs, and those programs interact with the database. So this is another way. The other ones are analysts or sophisticated users who are using certain query tools to perform analysis of their data. So those users also exist over here. And then there can be data administrators as well, because they have to the database administrator have to administrate the data. They may have to for those administration, they use the administration tools to perform certain operations of data. For example, they may be willing to create a new schema. They want to modify something, so they want to update database as well, because or they want to change the architecture of database or anything. All the types of administrative actions are performed through administrative tools by the database administrators. So database administrators are continuously working on the database to keep it optimized, to keep it in this best possible form. So these are the things we studied in the class. Now I want to know if you have any question. You have to answer my questions. Have you read the book? Have you read chapter 1 of book so far? Please raise your hand to tell me. Are you able to listen me? I'm not getting any response. You have read the slides, but have you read the chapter 1 of your textbook so far? Not yet? Okay, try to read your book chapter, because it is very important to read. If you won't be reading it, then you won't be able to perform your exercises, and you will be able to solve the questions. Yeah, I know that your assignments are quite much, and for this we are going to have a meeting tomorrow. Tomorrow morning our meeting is scheduled for all the instructors of this course, and we are going to decide something in your favor. So you have to be very patient. You have to perform assignments of this week, and for week 3 onwards we'll tell you about which assignments you need to perform. So all the instructors will decide something about assignments, and then we'll tell you. Okay? Okay, students, now I'm here. If you have read the book and you have some question in mind, please send me the message. And those of you who have not yet read the book, please read it as early as possible, because the contents of books are very important. You cannot rely on the slides and the material on Blackboard only. All the things you have to read. No, slides are not enough. You have to read, because as you see, the slides are not very textual as well. In this week, slides are having very few details. So for this you have to read your chapter of your book, so that you can answer me questions as well. So when I'll tell you when the material for a week will be sufficient, and then I can tell you that you don't need to read the books. But for this week, the material available over the Blackboard is not sufficient. Only a few lecture slides. So you need to go through your book in detail and perform your assignments. So I'm available here, and its time is 6:40. So I'm available over here till 7. So you can ask me question if you want through your chat. Okay, I'm going to turn my mic off. Okay, let's hope for the best, whether you are going to receive good news or not. But I'll try my best to give you a suitable, moderate number of assignments. I'll try to make all of them agree over it. Okay. Okay, students, thank you. I'm here. If you have any questions, please send me a message or raise your hand. I'll answer it. Okay. Thank you. Okay, so since you have asked about assignments, so for this week you have to perform your assignments, and I can see the list of in the assignment. It's not too much. For example, if I ask you, it's written that complete the following practice exercise from your textbook. You have to perform practice exercise 1.1. The question is, you have to give 2 disadvantages of database systems. There are several advantages I mentioned in your chapter. First chapter, you have to give 2 disadvantages. So this is not much difficult. It's not going to take much of your time. Then the question number 1.3 is, you have to list 6 major steps that you would take in setting up a database for a particular enterprise. So when you read your chapter, you will find that there are certain steps which you need to perform. You have to define your database schema. You have to design. You have to design it. Then you have to write your queries to access it. There are certain steps to then. As I also told you that there is an application layer, there is a storage manager. So you have to write you can write many steps, but you have to write 6 major steps to to set up a database. Then you have to perform question number 1.5. The question is, suppose you want to build a video site similar to YouTube. Consider each of the points listed in section 1.2 as disadvantages of keeping data in a file processing system. Discuss the relevance of each of these points to storage of actual video data and to metadata about the video, such as title, the user who uploaded it, tagged, and which users viewed it. So in this way you are saying, because YouTube is keeping track of how many times the video was viewed, when it was uploaded, when it was accessed last time, and how many times it was accessed. So it is recording certain attributes about every video. So first you need to identify that about a video, which attributes YouTube keeps track of in its database. So then you can see that then you have to mention the disadvantages of keeping data. If you keep the data about all these things in a file, so the disadvantages of keeping data in a file, all those disadvantages will be applicable to the website of YouTube as well, the website similar to YouTube as well. So you can refer to all these things over here. Then there's a question about 1.6. Keywords queries used in web search are quite different from database queries. List key differences between the two in terms of the way the queries are specified, in terms of what the result of a query. So when we say keyword queries are given in web search, then for web search there are web crawlers who need to crawl to different websites and then search for the websites with having the same keywords, having the similar keywords. And when you search from a database, the database is stored at a single location. There is no crawler required, and you can search from a single database, from a single field as well. So you have to just tell about the differences from accessing between the two. You are searching a keyword from a database, and you are searching a keyword from the web. So first you need to study how a keyword is searched from a database. Then you search it. Then you see that how search is performed over the web. What happens when you type a keyword and Google search for it. So when you know that how these searches are performed, then you can tell about the differences. So these are only 4 questions for this week which you have to perform. These are not too much. So please go through it. And I don't see a submission folder over here. So have you found submission? Have you found a way to submit your assignments? Okay, now what you can do is, because there is no submission folder over here, you can do is to you can submit it through email. Because there is no submission folder and it will take some time to resolve this problem. If you find some submission folder over here by Saturday or by the end of this week, then you can submit in the submission folder, and if you don't find submission folder over here, then you have to email me this exercise. The email subject should be your name and your roll number. Okay? Okay, you can send it as email, but as an attachment, but mention your registration number, your name, and your course as well. Okay, students, thank you very much. That's all about it. So if you have any question, please tell me. No questions? Okay. No, for this week you have to perform all the assignments. And in that course you are going to have, maybe you have to perform all the assignments in System Analysis and Design course. Yeah, for that course the number of assignments is quite large because that requires much practice. Okay, we'll talk about it in a face-to-face class. You need to perform this week assignment, and in week 3 we'll talk about it in our class.